So hi all, today we will see this question. The question is job sequencing problem. This question was asked yesterday in the POD series. So given a set of n jobs where each job has a deadline and profit associated with it. Each job takes 1 unit of time to complete and only one job can be scheduled at a time. We earn the profit if and only if the job is completed by its deadline. The task is to find the number of jobs done and the maximum profit. See, what is this question saying? Basically, the structure for a job I looks like we have an ID, then we have deadline, and then we have profit associated with it. And what is a task that I have to do? I have to maximize this profit and count the number of jobs that I can perform. But what are the constraints for doing a job is, see, one job takes 1 unit of time only. That is, you can assume that one job will be completed in 1 day only. And no two jobs should be done on the same day. No two jobs on same day. So see what we can do. Let us try thinking of its greedy approach. So see, let us try to be greedy. So if I have to maximize the profit, what I will do? I will try to take the job who has the maximum profit, which is this in the case. It has the maximum profit. So now my count becomes 1 and profit becomes 40. Now what else is the second maximum? This is 30. But see, this job is completed on day 1 and this will also be done on day 1 only. And since no two jobs on same day, so I cannot take this one. So what else I can take? I can take this one, 20. So the count will become 2 and the profit will become 60. So after this, what I can take? This one. But see, this is also being done on day 1 only, where this task is already being done. So we cannot take this. So the answer is 2 jobs can be done with the maximum profit of 60. Okay. So let us discuss the greedy approach that we did now. Let us discuss the algorithm for it. Like, what are the steps in a greedy approach? So see, first of all, what I can do, since I have to take the job who has the maximum profit. So I can easily sort the given array in decreasing order so that I can easily access all the maximum profit first and then the smaller profits. Decreasing order of the profit. Now the second is, see, we have total n jobs. And since each job is taking only 1 unit of time for completion, so there are total n time slots possible for us. 1, 2, 3 and 4. And if any job has the deadline after it, we will still try to complete that in this given time slot only. See, if for a job I have a deadline for, so I can complete that task on day 1, on 2, on 3 or on 4. There are many options. But we will try to complete the task on the greatest possible time so that in the shorter times the task who has the shorter deadlines can be done. So what we will do, we are sorting the vector into the decreasing order of their profit and now we will simply check if the time slot is free, then we will assign that. So basically the greedy approach says first we have to sort the given vector into the decreasing order of the time. So what would be the sorted jobs array looks like? So it would be 3, 1, 40, then 4, 1, 30, then 1, 4, 20 and then 2, 1, 10. This is some sorted array which is this is ID, this is deadline and this is profit. Okay. Now I will try to take the job who has the maximum profit if this time slot is free. Now how can I check if this time slot is free or not? I can maintain one array. Okay. So let's say this is the array of slots where all the possible slots we have 1, 2, 3 and 4, which is the size of the jobs array. These are the possible time slots, and initially let's say all the time slots are free, that is all have the value false. So whenever we are accessing a job, we will see if this deadline is free or not. So the deadline is 1. So let us see, is the deadline 1 is free? Yes, it is false. So if the slot of dead job's deadline is free, then what we can do, we can simply perform that task. And how to perform that task? We would simply add its profit to our maximum profit, and we will simply increment our count, and we will make this slot as true. That is, this slot is being occupied now and no other job can take this slot. So now I am at this position. So is this time slot 1 free? No, this is already assigned. Now the time slot is 4. Is this free? Yes. So we will make it true and we will take this in our profit. And now the time slot is 1. Is it free? No. So we are only doing 2 jobs with a maximum profit of 60. So let us take one more test case. So see, let us take some more test case, which is n equals to 5 and the job array is, suppose A 300, B 119, C 327, D 125 and E 2 and 50. So the first task is to sort the given array into decreasing order of their profit. So first it would be A 300, then it would be C 327, then it would be D 125, then it would be B 119, and then it would be E 2 and 15. And after this, we will try to make an array of total n jobs. So we have total 5 jobs. So this would be 1, 2, 3, 4 and 5. Initially, all the slots are free. So see, now let us take this slot. So this slot is being done on day 3. So is it free? Yes. So we can do this and our count becomes 1 and the profit becomes 100. So now we are at this. This slot is being done on day 3. Is day 3 false? No. So we will check for all the days beyond it, all the days prior to it, that is day 2. Is day 2 false? Yes. So we can complete this task on day 2. So now the count is 2 and the profit is 100 plus 27. Now this task on day 1, yes, we can give it. So the count is 3 and it becomes 25. Now this is day 1 is free, no. And does I have any days prior to it? No. So I cannot complete this. And this is day 2. So day 2 is already being occupied and day 1 is also occupied. So we cannot do this. So this was its answer. That is, for every job we will try, if the given deadline slot is free, then we will assign that task on that slot, and if not, then we will check all the previous days also. If any of the day is free, then we will assign it to that date. So let us try to code it. So see, I have to return a vector. So let us initialize a vector. And now see, first task is to sort the given vector. Given array, okay, we are given an array. So see, we have to sort them in the decreasing order of their profit. So we will make one comparator function, and what this comparator function will do, this will return the job which has a maximum profit. So job x job y. So if x dot profit is greater than y dot profit, we will simply return. Now this way we have sorted our given array. Now we will maintain one array slot for indexes n plus 1, and initially everything is false. Now after this we need to return two variables, count and total. Let's say total. Initially both are zeros. Now we will traverse our array, and now we will check for all its previous elements. So in any given array, so basically what we do, for any given element, if that day is not free, then we check for all of its previous days also. So that's why I'm running two loops. So the another loop will go from j min of n comma array of I. Now why I'm taking this min of n or array dot deadline? See, this might be possible that my deadline is higher than the size of the array. But since there are total n jobs and I have n slots available, so if it has to perform, it can be performed within it. So therefore, we are taking the minimum of it, so that we are trying to assign that job in a given frame only. And after this, we'll simply check if the slot j is false. That is, now we can assign it. So first we will make it true that we are assigning you a job now. Then we are incrementing our count. Then we are updating our total. The total will be array I dot profit. And now since we have got, then we don't need to check any beyond any previous elements, that we are breaking it. And after this, we have got our count and the total, and we'll simply push it into a vector. So result dot pushback count and result dot pushback total, and we can simply return the result. Okay. So yeah, the problem is successfully solved. But let us discuss its time complexity. So what is its time complexity? The time complexity for this in the worst case is n square, because for every job I am checking all the slots previous to it. So therefore the time complexity would be big of n square, and the space complexity would be big of n, because I am taking one auxiliary array. But the expected time complexity didn't fulfill. So how can we optimize it? So see, we can optimize it using one special data structure known as disjoint sets. So we will use disjoint data structure. So see, what is disjoint data structure basically? First, let us discuss what is disjoint set. So see, if I have a set like this, and suppose this is a subset of it, this is a subset of it. So see, suppose this has the element 1, 2, 3, and it has the element 4, 5. So see, both of these subsets do not have any element which is common to it. Therefore, these sets are disjoint sets. That is, the sets which have nothing in common. Now, disjoint set supports two operations. One is union and the other is find. So, let us discuss both of these operations. So, see what is find. Suppose I am doing find 2. So, what it will do, see, in a disjoint set, this subset, this all the elements belonging to a same subset will have the same representative element, and all of these elements belonging to this subset will have the same representative element. Now, if I have to check if two element belongs to a same disjoint same subset or not, what I can do, I can simply use the find operation, and if the return value of these find operations are same, that is they belong to a same subset. Suppose find of 2, so this will return one representative element. So let's say this is, let's say 31, and find of 3. Now, since this subset will have the same representative element for all of its elements, so find of 3 will also be 31, and since they are equal, so therefore we can say they belong to a same subset. But find of 4 will return some other value. Find of 4 and find of 5 will return the same value. Okay, so this is about the find operation. And what is the union operation? Basically, union operation, what we will do, if I write union of 3 comma 4, so what it will do, it will add this into this set only. So this was about the union and find. So see, we know that we have discussed this representative element thing, but how can we know what is the representative element? How can we find our representative element? So see, for this what we do, we make a parent array. We make a parent array where we assume that every element is the parent of itself. That is, 1's parent is 1, 2's parent is 2, 3's parent is 3, 4's parent is 4, smell for 5 and 6. And if the element and the parent of the element is same, then we simply return the element as a representative element. And if they are not same, then we recursively find for the parent element. Suppose this is a tree, and this is the parent element. So see, if I want to find the representative element for this node, and for this I am checking if the element and parent element is equal, and suppose it is false, then what it will do, it will call recursive function for its parent node. This is also false, so this will return the recursive function for its parent node. So now we are at here, and now when we are at here, the element and the parent of the element got matched, and now since they are matched, we will simply return the element as a representative element. So this is how we calculate the representative element. Now let us see this on our question. So basically now we will try to see our question and dry run it simultaneously, so that the approach would look more relatable. So see, this is the code that I've already written for it. So let us discuss the struct of it, and then we will dry run this approach so that it would be more realistic. So see, this is the struct for a disjoint set. It has a parent array, and basically this is the constructor. Whenever I am making an object for disjoint set, the constructor will get automatically called. So what it is doing, this is making a parent array for n plus 1 size, and initially what I am making the element as a parent of itself. And in the find operation, we have already seen what we do. If the element and the parent of element is same, then we simply return the element. Otherwise, we call the recursive find function for its parent element. And what does merge do? It adds the element as a child for another element. That is, we are making u as a parent of v. That is, v is a child. Now let us see the code and let us dry run it. So basically, this is my code. Let me just copy and paste it. So yeah, this would be properly visible. So let us see now. See what are we doing? In the question, we need two variables, count and total. We are initializing at 0. So see, initially I have this variable count 0, total 0. Now we are sorting the given array based on the comparator. And what is the comparator doing? Sorting the given array based on the decreasing order of the profit. So now my array will look like, so first this would be 3 140, then this would be 4 130, then this would be 1 4 20, and now it would be 2 1 and 10. So this is my sorted array looks like. And now what I'm doing, I'm finding the maximum deadline. So see, what is this function find maximum deadline doing? Basically it is just comparing every element's deadline to the maximum deadline so far and is returning us the maximum deadline. So basically what is the maximum deadline for a given array? Max deadline is 4. And now what I am doing, I am making an object for a disjoint set for this much size 4. So basically whenever I am creating an object, the constructor will get called, and what is the constructor doing? Simply making an array, parent array from 0 till n. That is, now I will have one parent array from 0 till n. And what is the n here? That is the maximum deadline 4. 0, 1, 2, 3 and 4, and every element is the parent of itself for now. This step is also done. So now what I am doing, I will traverse the given array. So initially my I is 0. So now when my I is 0, what I am doing, I am trying to find the maximum available slot that I have for this given deadline. So see, what I am doing, I am trying to find the maximum time slot that I can assign this job at. So what I will do, see, array I dot deadline. So what is the deadline for this? 1. And now what I am doing, ds dot find 1. So this function will return me the maximum time that I can assign this job at. So let us see the ds dot find function once again. So see, what is it doing? If the element and its parent are equal, we are simply returning, else we are calling the recursive function on the parent element. So if the element and the parent of element is same, then we are simply returning the element. That is, now we have got as an answer for available slot 1. And see, you can also see for this task the greatest time that I can assign is 1 only. So therefore I have got this. And if this available slot is positive, yes, that is, now we can assign this job. So what we will do, we will simply merge this. Basically what I am trying to do, I am trying to make a tree like this, so that whenever another job comes, the parent will be 0. That it would be know that 1 is not free anymore. You have to assign the maximum time slot available as 0 now. So what we'll do, ds dot find available slot minus 1. So what will this return? Ds dot find available slot is 1 minus 1 0. What it will return? Ds dot find 0. So ds dot find 0 will return is 0, and the current element same, yes, it will return 0 only. So since we have got 0 and we will call merge function for 0 and 1. So now what the merge function will do, see the code for it. We add a parent of v as u, that is parent of 1 is 0 now. That is parent of 1 is 0 now. And here we can see in our parent array now, we have clearly neglected the 1 time slot now. That is the time slot at 1 is no more available now. So whenever this will go to 1, it will see the 0 and not the 1. And we can simply update our count and update our profit. Now our array, now we will see when I is 1. So now my I is 1. So what would be my array 1 dot deadline? This is 1. And what is ds dot find 1? This is 0. Basically what it does is the element and the current element same? No. Then it will call again the ds dot find function for its parent node, that is 0. And is 0 and the current element same? Yes. So it will return the 0. So I am getting the 0. So is it positive? No. That means we cannot assign this task to any day now because they are occurring simultaneously. So that's why I am not going inside this loop, and this was all about when I was 1. Now we will see for I is 2. So when my I is 2, what I am doing, my deadline is 4. And now when I am doing ds dot find 4, is the element and parent same? Yes. So I will be returning 4. Is this positive? Is this positive? Yes. So if this positive, we will try to find available slot for its lesser element, which is 3 only. And we will call merge function for 3 and 4, and we will update this parent node to 3 now. Okay, and now the count becomes 2 and the profit is 60. And now my I is 4. Now my I is 3. And now when my I is 3, we will find the available slot for this deadline 1. And what is the available slot for this deadline 1? This is 0. And is this positive? No. So we will not go inside this. And this was about our answer. So basically what I am trying to do initially, I am calling the find function for every deadline. That is, I am trying to find the greatest possible time slot that I can assign this job at for every job ID. And now if the time that I have received is positive, that is, I can assign the job, then I am assigning this. And if not, then I am simply not doing anything and simply iterating forward. This was all about this question. And now the time complexity, space complexity, everything is fulfilled. So I've also discussed the code and dry run it. So this was all about it. If you still have any doubt, feel free to comment. Thank you.